Welcome back to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the world of containers. Before we begin, I'd like to remind our listeners to rate our podcast on whatever platform you're using. Your feedback helps us improve and reach more people interested in Kubernetes. Now, let's get started with today's topic, Docker basics. Victor, are you ready to set sail on this Docker adventure?
Absolutely, Sheila. I'm excited to explore Docker with our listeners. It's a crucial technology in the container ecosystem, and understanding it will help us build a strong foundation for our Kubernetes journey.
Great. Let's kick things off with a fun quiz question for our listeners. What's the name of Docker's official mascot, and what type of animal is it?
Oh, that's an interesting question, Sheila. I love how you're connecting Docker to its visual identity. It's a great way to make the topic more memorable for our listeners. Without giving away the answer, I can say that this mascot perfectly embodies the spirit of Docker. It's playful, agile, and always ready to navigate the seas of containerization.
Exactly, Victor. Now, let's dive into Docker basics. Can you start by explaining what Docker is and why it's so important in the world of containers?
Certainly. Docker is an open-source platform that allows developers to build, package, and distribute applications along with their dependencies. It uses containerization technology to create lightweight, portable, and self-sufficient containers that can run consistently across different environments.
That sounds really useful. So, if I understand correctly, Docker helps solve the "it works on my machine" problem by packaging everything an application needs to run. Is that right?
Exactly, Sheila. That's a great way to put it. Docker ensures that an application runs the same way, regardless of where it's deployed. This consistency across development, testing, and production environments is one of the key benefits of using Docker.
Now that we understand what Docker is, can you explain its architecture? I've heard it follows a client-server model, but I'm not entirely sure what that means in this context.
Of course, Docker uses a client-server architecture. The Docker client is what users interact with through the command line interface. It sends commands to the Docker daemon, which is the server component. The daemon does the heavy lifting. It builds, runs, and manages Docker containers. There's also a Docker registry, like Docker Hub, which stores Docker images.
That's helpful, Victor. So if I wanted to start using Docker, what are some basic commands I should know?
Great question. Let's go through some essential Docker commands. First, we have Docker pull, which downloads an image from a registry. Then there's Docker run, which creates and starts a container from an image. Docker build is used to build a Docker image from a Dockerfile. Docker ps lists running containers, and finally, Docker images lists available images on your local machine.
Those seem like important commands to remember. Speaking of building images, I've heard about something called a Dockerfile. What exactly is that, and how does it relate to Docker images?
A Dockerfile is like a recipe for your container. It's a text file that contains instructions for building a Docker image. Each instruction in the Dockerfile creates a layer in the image. Common instructions include from, which specifies the base image, run for executing commands in the container, copy, or add, for adding files from your local system to the container, and cmd, which specifies the command to run when the container starts. When you use the Docker build command, Docker reads these instructions and creates an image based on them.
That's fascinating. It's like you're giving Docker step-by-step instructions to create the perfect environment for your application. Now, I've noticed we've been using the terms image and container a lot. Could you clarify the difference between these two concepts?
Absolutely. Think of a Docker image as a blueprint or a template. It's a read-only file that contains the application, its dependencies, and instructions on how to run it. On the other hand, a container is a runnable instance of an image. You can create multiple containers from the same image, each running in isolation. To use an analogy, if a Docker image is like a cake recipe, then a container is like the actual cake you bake following that recipe. You can bake multiple cakes, containers, from the same recipe, image, and each cake exists independently.
That's a delicious analogy, Victor. It really helps clarify the relationship between images and containers. Now, I'm curious about how Docker compares to virtual machines, which were widely used before containers became popular. Can you explain the key differences?
Great question, Sheila. While both Docker containers and virtual machines, VMs, are used for isolating applications, they work quite differently. Let me break it down. 1. Resource usage. Containers share the host OS kernel and are much lighter, typically starting up in seconds and using less memory. VMs, on the other hand, run a full OS and take longer to start, using more resources. 2. Portability. Containers are highly portable and can run on any system with Docker installed. VMs are less portable due to their larger size and full OS. 3. Isolation. VMs provide stronger isolation as they have their own OS, while containers share the host OS, offering lighter isolation. 4. Performance. Containers generally offer better performance due to their lightweight nature and direct use of the host OS. 5. Use cases. Containers are ideal for microservices and applications that need to scale quickly, while VMs are better for running applications that require full OS isolation or different OS types on the same hardware.
That's a comprehensive comparison, Victor. It seems like containers, and Docker in particular, offer some significant advantages in terms of efficiency and scalability. Before we wrap up, do you have any best practices or common pitfalls to share with our listeners who are just starting with Docker?
Absolutely, Sheila. Here are a few tips. 1. Keep your images small by using minimal base images and removing unnecessary files. 2. Use multi-stage builds to separate build time dependencies from runtime dependencies. 3. Don't run containers as root unless absolutely necessary. 4. Use Docker Compose for managing multi-container applications. 5. Regularly update your base images to get the latest security patches. A common pitfall is not properly managing data persistence. Remember, containers are ephemeral by default, so use volumes or bind mounts for data that needs to persist.
Those are excellent tips, Victor. Now, before we end, let's reveal the answer to our quiz question. The official Docker mascot is named Gordon, and it's a turtle. Turtles carry their homes on their backs, just like how Docker containers carry everything they need to run.
That's a perfect analogy, Sheila. Just like turtles, Docker containers are self-contained and can swim in any environment.
To summarize today's episode, we've covered Docker basics, including its architecture, key commands, Dockerfiles, the difference between images and containers, and how Docker compares to virtual machines. We've also shared some best practices for using Docker effectively. Remember, listeners, Docker is a powerful tool that simplifies application deployment and ensures consistency across different environments. It's a fundamental technology in the world of containers and a stepping stone to understanding Kubernetes. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy containerizing.